morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do a code review for you. And on this code review, I'm going to do it on the Space Shuttle Challenger O-ring damage. There are CSV files on the internet for the O-ring damage, but I wasn't able to find the CSV file that I needed. So I created the data frame within the R program because we're going to be doing this code review in R, which is a statistical programming language. And so we created the data frame using temp there were 23 missions on the Space Shuttle Challenger, and we checked the temperature of each mission on the Space Shuttle Challenger, and then we checked the damage to the O-rings on each one of those missions. And so you can see the damage to the O-rings as well. And so what we did is, after we created our vectors, we created a data frame from the vectors using the temp vector and the damage vector, and then we created the O-ring data frame, and you can see the O-ring data frame right here. And I'm using my compiler because I can no longer use Replit because Replit is not free anymore, and I'm only able to use free resources. And so as a result of that, I found my compiler. My compiler allows you to carry out graphics, which a lot of the compilers won't allow you to carry out graphics, but my compiler actually does. So we created the data frame. So you can see the data frame here. You can see there's 23 missions. And I think the last mission, the Space Shuttle Challenger exploded. So we had no more Space Shuttle Challenger. So what we want to do is we want to be able to use the columns of data to make statistical operations on them. So in order to make the columns of data, in order to carry out statistical operations, we use the attach function. And what that attach function does, it allows you to use the columns of data. So that's what we used. And then we're going to use a linear model, which is linear regression. So O-ring.lm equals LM damage temp. So your damage is your Y variable and your temp is your X variable. And then what we do is we do a summary of that. So the summary of that, it gives you your minimum, your first quartile, your median, your third quartile, and your maximum. And then it gives you the coefficients. It gives you the residual standard error and some other things. And then what we want to do is we want to make a plot of the damage and the temp. We're going to do that. And that's the great thing about the R programming language, because the R programming language has the visuals already programmed inbuilt into the function, into the program, so you don't need to import libraries. Whereas if you're using another programming language such as Python does not have the visuals automatically programmed inbuilt into the program. So you have to use import libraries in order to be able to use visuals. So that's a good thing about R. It's got the visuals already inbuilt into the program. So this is what we've got. And you can see here that the lower the temperature, the greater the O-ring damage. So that was pretty interesting. And then so what we want to do is we want to put a line in there. So the line, we're going to put a fitted line of the temperature into O-ring .lm, and you can see this is the line here, and so it's the x-axis starts at around close to 80 degrees and it ends at close to 55 degrees. And you can see that the higher the temperature, the more the ring damage. Excuse me. The lower the temperature, the more the ring damage. So we check the coefficient, and so the coefficients of the data frame, we can check the coefficient, and then we did some things to do with when the Challenger exploded, the temperature was 31 degrees, and so we put a formula in there for when that occurred. And then we're going to do some more formulas for the posterior prediction interval, and it's the same as the frequentist, and the posterior probability that damage index is greater than zeros. And then so basically there's some more formulas in there as well, because at the moment I'm studying Bayesian statistics, and so that is related to Bayesian statistics. And I'm still learning that, but basically what you're using is you're using the Bayesian formula to calculate things, the posterior prediction interval and the posterior probability interval. And that's just, it's the formulas that I was able to get from the course that I'm taking, and then I had to just copy the formulas from what he had put down in his lesson plan onto this program. And so that's just telling you some things about Bayesian statistics, which the person who gave the course, I'm assuming he's a PhD, so he knows much more than I do. I mean, I'm assuming he's got a PhD in statistics, so he's much more knowledgeable than I am. So those are just formulas that he has put into the system, and I copied them. But what that does is that gives you information about when the Space Shuttle Challenger exploded, which was at 31 degrees Fahrenheit when that happened. So I've covered pretty much everything that I wanted to cover in this code review. And as you can see, this code review is different from a code review that I would do in Python. And I'm going to go ahead and do a code review in Python just so you can see the difference between R and Python. And since I've been working with Python for 4 years now, I'm much more familiar with Python, and it's a lot easier for me to talk about the code than it is in R, because I don't use R a lot. But now that I've got my compiler, I imagine I'll be using a lot more of R. And what we'll do here is, since I said I was going to go ahead and go through a code review in Python, I'll go ahead and go through the code review in Python just so you can see it. And you'll see that I'm much more knowledgeable Python than I am R, because I use Python a lot more. And the code originally was in R, but since I know Python so much better than R, I decided to go ahead and do it in Python as well. And so what I did was, this is for the Bayesian statistics course that I'm taking on YouTube. So this is the Space Shuttle O-ring damage. And so for this program, what I had to do was I had to import my libraries. I imported Pandas, NumPy, sklearn, and Matplotlib. and then I had to define the data set the same way that I did it in R. And the reason why I did that is because I couldn't find a suitable dataset CSV file on the internet. And since I couldn't find a suitable CSV file on the internet, I just had to make my own. And so I created a data frame with pandas. And so you can see that this is the pandas data frame here. You can see we had 23 missions in total, and it gives you the O-ring damage. So we define our X and our Y variables. Our X is the temperature of the O-ring, and the Y is the damage of the O-ring. And then I decided to use two models. I decided to use the linear regression model and the logistic regression model to see which one worked best. And so when I did the linear regression model, it gave me an accuracy of 41%, which isn't fantastic. And then I plotted it onto a graph, but I used NP polyfit. In order to use polyfit, it was able to make a straight line, which is what we wanted. We wanted a regression line. So when we use NP polyfit, this is our X and our Y variables along with the regression line. So you can see here that the visualization or the chart that we created is pretty much the same as the chart that was created in R, with the exception that I had to use different coding to come out with the same result. And the thing is in R, you didn't have to use as much coding as you had to use in Python. The reason why that is because the visualization is inbuilt into R, but it's not inbuilt into Python. So I decided I wanted to do the logistic regression model, because in the logistic regression model gives you the ability to have more than just a 0 and a 1. In the logistic regression model in sklearn, you've got something called multi-class. And so the multi-class is set up for automatic in sklearn. So I didn't even have to set it up for multi-class, because it just automatically calculated the fact that it was a multi-class, more than two classes, and it gave you an 82% with the logistic regression. So even though it created the same visualization, it still gave you a different accuracy. So the accuracy for the logistic regression is going to be different from the accuracy with the linear regression. So even though in R it was a linear regression model, I just wanted to see which one was best. Was it linear regression or logistic regression? And you can use linear regression or logistic regression because it gives you the same graph, but logistic regression will give you a better accuracy, but it's not more accurate. It's just a better accuracy because of the way the accuracy is calculated. And then so what I did was I visualized the logistic regression, and this is something that I got off of sklearn, where it said where you plot the prediction on the X and Y values. And when we plotted the prediction on the X and Y values, this is what you got. But it's not necessarily what was in the R program, because the R program was a linear regression. So I went ahead and plotted it again. We plotted our coefs. We plotted what the coefficient was when it was 31 degrees, and that coefficient was 6.28. Plotted the intercept. And then now what we did was we plotted this logistic regression model using a linear regression theme, And then so now you've got the linear regression line on a logistic regression model, and you can see again that this visualization is the same as the visualization that we calculated for the linear regression model, and it's the same visualization that was calculated on R. So basically what happened was we've got the same plots and the same values, but we just went about them in a different way. So it's up to you whether you want to use R or Python. R is a statistical programming language, but I think that because now that all of these libraries have come out for Python, a lot of people prefer to use Python, but prior to all of these libraries coming out for Python, I think people prefer to use R. So I'm going to go ahead and conclude this video because I've covered everything that I wanted to cover. I've covered R, I've covered Python, covered linear regression, covered logistic regression. I've compared linear regression to logistic regression, and then I've covered the coefficients and the visualizations, and so I've covered a lot of information. So thank you so much for watching my video. If you like my video, please like and subscribe, and I will communicate with you soon about some more technical subjects.